Hello, this is renewable energies resources class video energy storage systems. Third topic that is superconducting magnetic energy storage SMES. Okay, it is a very cutting edge technology. Previous one was a fascinating technology. So these are our ChatGPT terms. So don't get confused. So it's a cutting edge technology which harnesses the unique properties. No need to write cutting edge technology only. These are terms we can adjust. Very good technology which harnesses very unique properties of superconductors to store electrical energy in magnetic fields. It offers a highly efficient and responsive energy storage solution with virtually so self-discharge and with no self-discharge and a long lifespan. Okay, understood. It has got a this is very good technology. Store electrical energy in a magnetic field in the form of magnetic field. It is very highly efficient and there is no self-discharge and therefore it has got a long lifespan. That's what the sentence says. Okay, now working principle, charging phase. Again, same thing will be here. Also will be here. Phenomena of superconductivity. Certain material exhibit zero electrical resistance when cooled to extremely low temperature. That one it is saying. So charging phase, that is energizing the coil. So energizing the coil, the direct DC, direct current. It is passed through a superconducting coil and creates a very powerful magnetic field within the coil. This magnetic field stores the electrical energy. We'll see the image. Okay, so by using the setup, okay, which side it goes? Okay, so this is the cryostat. Okay, there is a positive, negative charge setup using using a cryogenic refrigerator, using helium nitrogen storage, using superconducting low temperature, high temperature superconducting magnet. It is used. Okay, now again we'll see going back. Okay, so the DC, it is passed through a superconducting coil. Okay, direct current is here, plus minus. There the current is supplied whenever we have high energy supply available, then the current it is connected here, the plus minus sign there it is connected, so that the coil get become it act as a magnet. Okay, you know, when current pass through a coil and when the material having the magnetic property is kept there, it can be made as it can storage, it can convert into a super magnet, and it can convert into super magnet by controlling the temperature. So this is a refrigerator. It's a cryogenic refrigerator. It can cool to very low temperature, below room temperature, and at that stage, normal air is not used. Helium or nitrogen gas is used inside that. So, so by using the DC direct current through a superconducting coil, which creates a very powerful magnetic field within the coil, and this magnetic field it stores the electrical energy. And during discharging, when we need the electricity, the current flow it is uh, reduced, or there is no DC supplied into the magnet. The magnetic field collapses and it induces the current flow in the coil, which is then converted into alternating current and delivered to the grid. Okay, so it is reversed. Whenever we need, the process is reversed. Whenever we are not giving energy, that time only it started reversing. Okay, now these components, superconducting coil, the which is the heart of SMES. Okay, means it is a very important component. That is the meaning of superconducting coil as a heart. No, don't need to say that SMES heart is superconducting coil. Nothing like that. The term is used to highlight that is very important one. That's only the meaning. Some people I have seen there by heart the same thing and write it is heart of this. Yes, it's a very important component. Okay, now this coil it is made up of a superconducting material. superconducting material, that is niobium titanium. This you have to by heart, no other option. Niobium titanium or niobium tin. Nb3, 3 should come down. Okay, Nb3 means 3 Nb atoms and 1 tin atom. That is niobium tin. The coil is wound into a specific geometry to maximize energy storage and maintain. So the coil, it is surrounding that material made up of niobium titanium, or the coil which is made up of niobium uh, titanium or niobium tin. To that the current coil, it is wound in a specific geometry in arranged way. Trial and error method, they found that a particular geometry, if they use specific geometry, if they use, maximum energy can be stored in that. So that way it is stored, means to get maximum energy, the arrangements are done. Now the cryogenic system, superconductors, it requires extremely low temperature to operate, that is around 0 Kelvin, that is minus 273 degrees Celsius. That's why we have this cryogenic refrigerator system with helium nitrogen supply to that. Okay, so the cryogenic system usually employing liquid helium. It maintains a superconducting coil at a required temperature. Now we have power conditioning system. It converts the AC power to a DC. That is not given here as such. Here above this, we have above this battery, the plus minus sign. We should have the power conditioning system, which converts the AC power into DC and gives to the coil. And whenever we need electricity, the DC should be converted back to AC. That is the power conditioning system. Now control system, a sophisticated control system which manages the operation of SMES system. SMES means a super magnetic energy storage system, regulating the charging and discharging process, monitoring system parameters, and ensuring the safety. Okay. Now the thermal insulation, to minimize the heat transfer and maintain the superconducting state, the coil and cryogenic systems are housed or kept within a vacuum insulated enclosure. Now the merits and demerits. Very high efficiency, 95% efficient. Fast response time, similar to the flywheel electricity storage, means as soon as the electricity supply demand needs, immediately start giving the electricity for energy back. That is fast response time. Demerits, high cost due to expensive superconducting material. The material which used, the magnetic material, is very high costly material. And limited storage capacity, that storage capacity is limited, not very high. Then it has got a high cost due to demerits. It has got high cost due to the expensive superconducting material. And it has got limited storage capacity, complex technology with high maintenance requirements. These are the demerits, because okay, you see, superconducting materials are very costly. That's the first point. Storage capacity is less. It's a smaller device, not a very big device. And it is a little bit complex technology. Cryogenic required helium, required the superconducting magnet material required for the vacuum, all those required, and it should be thermal insulation required. So little bit complex technology. Therefore, maintenance requirement is also very high. So that's about this super magnetic superconducting magnetic energy storage and devices. I'll stop the video here. Next one, that is supercapacitor.